fine also. So we'll start with why responsible AI, some of the problems with AI systems, and then we'll talk about fairness and bias, which is something that is talked about a lot when responsible AI is considered. I mean, how do you measure fairness? What is bias? What are the different definitions of fairness? Things like that. I'll do a demo of this IBM AI Fairness 360 tool, which is a nice demo, and I'll do it on the web itself. So you can also go ahead and try it out after the session and explore. And it's a library where you can also apply it to your own data sets. We'll talk about some of the facets of responsible AI, like reproducibility, accountability, security, privacy, and in the end of the session, talking a little bit about privacy-aware AI. This is again a very emerging area, especially in the medical domain when there is sensitive patient data. How do you keep the data private and at the same time build AI models? So I'll touch base on some of couple of technologies which try to focus on that. So that's what I'm going to focus on this session. So let's get started. Just a little bit about me, and Dr. Anushri already introduced me, so I'll just keep it brief. I wrote the book Terrace to Kubernetes by Relay Publications. I was at GE for 19 years. It was more of an engineer. I'm a mechanical engineer by education, and I was working for GE Research first, then GE Power, and then GE Transportation. And last 2.5 years, I'm with Persistent. Persistent is a global company. There you see, we are like a $500 million company. We have more than 10,000 employees all over the world. We are a global company. I'm from Goa, so I wanted to move back to my hometown. So I'm based out of the Goa office. Persistent has a nice, like a 500 people office in Goa, so I'm based out of there. But I lead a global team for AI research. We have folks in US, UK, in Singapore and other areas. And a lot of my team's focus is on looking at the state of the art in AI and looking at the latest research that are published. We publish a lot of research around, especially on NLP, knowledge graphs, etc. And then how to consume that research, apply it to real world problems, and productionize those AI models. That's kind of what my scope is. Uh, my team's focus. And then some of the verticals that our customer base, we mainly focus a lot on banking, BFSI, banking, financial services, insurance. That's our primary business focus. We are a lot in healthcare and life sciences, and growing vertical for industrial and some of the high-tech software partnerships that Persistent is developing. So when I worked at GE, I was in Bangalore, and there was a triple IT Bangalore, which was right next to us in ITPL. So I had a lot of friends and a lot of folks from triple IT actually joined GE also. So we had a very good relationship with triple IT in Bangalore. So even with Persistent, we do a lot of internships and collaborations with industry, and we are actually looking forward to some really smart folks joining our team. So definitely we'll stay in touch after the session also, and if there is any such things like Professor said, we can discuss and maybe have some students help us out in some of these AI projects. So let me get started with the session. So to start off with, let's see why we need responsible AI. And do interrupt me if you have any questions, specific questions, or if this is going too fast or too slow. Do let me know. So why do we need responsible AI? So the first aspect is an ethical concerns, which is mainly what this section will focus on. So what are the ethical concerns? So typically when you build this machine learning models, you train them on data, but these tend to be black box models. You don't really know what is happening under the hood. So, and maybe some straightforward models, like if you look at linear regression, logistic regression, even random forest or decision trees to some level, you can understand what is going. But as you get to bigger models, you look at the neural networks, the multi-layer perceptrons, and then you look at the convolution neural networks or the new transformer models. It's very difficult to understand why the model made a particular decision. So as we say, data is the new oil. Now these companies have huge volumes of big data, and it is said that not the company with the biggest technology, but the company which has the biggest data will actually be the one that is successful in the market. So traditional companies like GE, they are focusing a lot on having data, collect data from the equipment. And earlier, this was just stored on tape drives, and nobody really looked at it. Now there's an active effort to take that data, put it in a consumable form, maybe in historians or in databases or real-time databases, and consume it. So data is definitely the new oil of the new economy. And at the same time, what makes the data valuable is the algorithms that you run on it. And there's only so much you can do with the rule-based algorithms. And definitely, they incorporate a lot of domain knowledge. But where we are going is Dr. Andrew Ng kind of termed this coin or termed this phrase: AI is the new electricity. So we're looking at AI being the engine by which this huge volume of big data will be processed and new outcomes will come out of it. But as we are going ahead and building this amazing solutions in AI, I mean, you must be hearing in the news, AI is helping detect cancer better. They are detecting helping detect fraud in banking. But as this as AI is kind of consuming the world, we are also seeing that we need to have this AI become more responsible. Just like the phrase goes, when with great power comes great responsibility. So we are also seeing this headline like this. I just picked up some headlines from the news. Amazon introduced this facial recognition software, but then it actually matched some of the members of Congress, some respected politicians, to faces of mugshots. Then there was this algorithm that was used to grade students' essays, and that was flawed, and it was uh, it was actually giving an incorrect grade. Now, healthcare system, modern healthcare, a lot of insurance companies use AI to detect the risk of a patient. Now, if a AI algorithm is detecting that how much insurance is coverage you are going to get, then you better have that algorithm be accurate and not have a bias against certain unwanted features like race, gender, and things like that. Same thing when we are having AI algorithms in banking, which is a major area where persistent plays. Algorithms in banking which are detecting the risk of a default of a loan. Now, those algorithms need to be fair. They should not be biased against unwanted features. And that is what responsible AI tries to do. So as we build better AI systems, we need to be sure that these systems are not biased and they are kind of we understand what is happening under the hood. The second aspect of responsible AI, I would say, would be the hidden technical debt in ML system. So this is a nice paper by Google, which was where they actually show that. From this is the screenshot from the same paper. Basically, a fraction of the work involved in real world scenario in production is actually in ML code. Because today these libraries are pretty standardized. Like even if you have the state of the art text processing using transformers, there are standard libraries uh, which can give you. I mean, you can have a model trained on a large corpus and get the model. So the actual ML code is becoming less and less in volume, and now there are like low code and no code ML tools like this Astro.ai. It's a very powerful tool which can let you build a model, machine learning model, without writing a single line of code. It is a very intuitive UI. You do a drag and drop, and you can build a machine learning model. So what we are seeing is in production, more work is going on in configuring the data, collecting data, extracting features from the model, cleaning the data, extracting features, verifying the data is correct, managing resources for your machine learning training, like managing GPUs, TPU, how to manage this distributed resources, doing the analysis, doing the process management, having a workflow for approval and things like that, and then serving infrastructure. So how do you serve this machine learning model? And finally, can you monitor the machine learning model? Like typically, we see, okay, we build a nice machine learning model on some data we downloaded on Kaggle, and now we deploy it in production. 9 times out of 10, that model is going to have issues working on real data, because the real data is very different from the standardized golden data set that was made available to you while training. So in real world, when the model works on a real data set, they tend to degrade in performance due to data drift that happens, concept drift that happens. Maybe some of the features you have correlated are not actually correlated in real world. So it is very important to continuously monitor your model and make sure this feedback gets back into your model development lifecycle. And the model training has to be like a continuous cycle where you do a continuous integration, continuous deployment for ML. Just like in the software world, you follow the agile practices and build like a CI/CD pipeline for deploying code. So also you need a CI/CD pipeline for machine learning, and I'll show some best practices how we have done that. But long story short, what we are seeing is a major part of responsible AI is when you build machine learning model and deploy something, you tend to build a technical depth, and you need to work on these different facets of a machine learning pipeline to make sure that you reduce the technical depth, so that next time you deploy a new model, you don't end up working on the serving infrastructure that is standardized. So in the industry, you'll see a lot of platforms which are focused on ML ops, like DevOps applied to machine learning. So these are standardized platforms which let you build a machine learning pipeline And then as you build new models, you can apply those models in a standardized way. So you don't have to do a lot of work and try to mitigate the technical debt that you have built. So these are the two aspects. I would say one is the ethical aspect and one is the technical depth aspect for ML ops. These are the two reasons which are, I mean, there are multiple things, but these are the two reasons that AI systems kind of need to focus on responsible AI. And now let me show some examples of problems that we face. But before that, I'll just take a break. Any questions or is the audio clear and the screen is refreshing fine? Okay. Um, so you can still hear me all right? Just to check.
Yeah, yeah.
Okay. So let me share some problems that we see in the AI systems. And this is something that you'll probably, I mean, you keep hearing these headlines now and then. One of the things was this gender shades. So this was So Gender Shades is a nice tool. It's a website that was actually developed by some of the Google researchers at the time, including Timnit Gebru. She's the one who recently was in headlines because she was the heading the AI ethics at Google, and Google had to let her go. And there was a lot of discussion around that. So Gender Shades is basically a website that looks at your facial detection systems. Now, a couple of years back, facial detection was the number one thing in AI, where can you detect faces and recognize the faces. So a lot of the big companies like Microsoft, IBM, Baidu, they had this facial detection engines available in the cloud. Like Amazon had this, I think, Recognize, and Microsoft had some Azure services. And these were detecting faces of individuals from photos. Now, what Gender Shades does is it looks at the different uh, type of people, the different features of the people, and tries to see how well the algorithm performs on certain people, like people with darker skin and people with lighter skin, males versus females. So this is just a two level of what do you say, the slicing that the Gender Shades does. So it took some samples of images from the internet, uh, uh, took some samples of images from the internet and divided them into these categories, like male, female, lighter, dark, and then tested the standard algorithms in the market, the cloud-based algorithms, and you could see the results. The algorithms performed really well when there was a lighter male. So for a lighter male, the accuracy was very high, but if you look at some darker female, it went into the 60s and 70s%, moving down from the 190%. Similarly, a darker male was also okay, but then it was not as good as the a lighter male or a lighter female. So you could clearly see that and this was done after the algorithm was deployed. So this is not something which was done during development, but you could clearly see that there is a bias the algorithm has on a particular type of individual. And if you're just looking at a face detection algorithm, ethically you would not want the algorithm to distinguish between a darker female and a lighter female because you're only interested in algorithm detecting the face. So this was a bias that was unintentionally in the facial detection systems. And in this example, it's a nice, cute example. It doesn't cause a much of a damage, but imagine having such a thing that detects the risk of a person committing a crime just based on detecting the face. Now, uh, if you would give a high risk to a particular individual based on an unwanted feature like the color of the skin or the gender, that will cause a problem. And that is how the problems have come. Ethical issues come into AI systems. You have these models which people don't consider to test it for the ethical test it for ethics for certain groups, and they tend to have these biases. Another example, and you can go to the Gender Shade website. They have a very nice UI. You can actually run this test by yourself and see how this bias is being shown. Another example, Amazon, they included a recruitment tool. They developed a recruitment tool, and this was something that was it was going to look at profiles of candidates, the CVs of candidates, and it will shortlist some of the CVs. As you know, looking through hundreds of CVs for a HR representative would be a pain, and this was meant to ease their job. But then what happened was because this was collected on a training data over past 10 years, it found they found that there was a bias in this tool. It was biased against women. So if it was a woman candidate, even though she was qualified, it will have a bigger chance of rejection than a male candidate. So this was a major issue that was highlighted, and Amazon was pretty honest enough. They actually admitted that this was an issue and they scrapped the tool. So this is again an unwanted bias that crept in, and this was an example of a bias that came because of historical data, because they didn't want the bias to be there in the system. They just collected historical data. Historical data had bias because over the years they could see that the series that came in, the female candidates were not that qualified, and because this was over the period of 10 years, and then because of that, that bias crept in the system. But now when they apply it to the current system, that bias is not valid. So this also reflects the thing of data, the concept of data drift. Like the distribution of quality of resumes was much different 10 years ago than it is now. But then that bias from 10 years ago when the data was collected is still active in the system. So they had to, in this case, they had to scrap the system. But you need to keep monitoring your ML models to make sure that the bias from history doesn't come back. Next example is this Apple. Even Steve Wozniak, the former founder of Apple, he himself tweeted that his credit limit was 10 times more than his wife, though they had the same exact transaction, same exact history. So this was a major thing. It was highlighted on CNN also. There was a major gender bias for the card. Now, in this example, what Apple did was they chose to ignore the gender. So, and this is something when we talk to data scientists, that is the standard approach data scientists tend to take. They said, okay, I have collected data, but I'm going to ignore the gender column. So I'm not worried about the gender. Sorry, I'm just going to take all the features in my data set and use those features to detect the risk of defaulting a loan. So I will just look at that features as I will choose to ignore gender as a feature, and I should be fine. But in this case, Apple did the exact same thing. They decided to ignore gender. But when the post analysis was done, it was found that the gender actually played a role in making the decision. Because of this, females were given a lower line of credit, though that was not the intention of Apple. And this is where, if it was a rule-based system, they could have easily checked what was going wrong. I mean, they would have said the rule that would say based on the gender, allocate that much weightage to your credit line would not be there at all. So you wouldn't have to worry about this for a rule-based system. But because it was a machine learning system, they had to rely on the data, and the data had the inherent bias. And though they decided to ignore the particular gender column, because the correlation between columns, gender did creep back in, and there was a major issue. So Apple Card decided not to see gender, but it was still an issue. So this was a very famous example of recent example of bias in machine learning systems. And last example, this is something I'll talk about on even for the IBM AI fairness demo. I'll talk about this. This is the recidivism algorithm by the Compass tool. So Compass tool is something that was developed by one of the by the U.S. government, U.S. federal government, and they used it to decide the risk that a particular person in a particular convict was would commit the crime again. So that is what recidivism is. Is will that person commit the crime again? So it was a bunch of questionnaires, like based on the and bunch of personal details of the convict, like it was the sex, the gender, uh, the race, the address, the locality where they lived, and some questionnaire answers. So either the convict would himself or herself fill that in, or somebody else, the warden, will fill that for the convict. And based on the response of the questionnaire, there was a software that will create a score for recidivism, saying that the person is that likely to recommit the crime and come back. And based on that, the judge would actually decide the sentence based on the responses to this. Now, ProPublica, which was a major publication, they did a lot of analysis in Python and R, and they took some sample of convicts, and they showed that this was heavily biased towards race. So they actually, this is a very nice article. I highly encourage you to read this from ProPublica website. They saw that certain individuals, when the Compass software gave them a low risk, they ended up committing a bigger crime, while certain individuals that were supposed to be high risk, just because of the race that they were in, just because of their race, they actually ended up living a very normal lifestyle and did not commit crime. So this software, they actually proved it as a paper that this was a heavily biased software towards race, and it had a major bias. It was also a gender bias, and this data set is, this is a very famous ethics AI ethics case study. This is something that is often cited by many institutions, and the data set is also made available by ProPublica. And I'll show an example of this when we do the IBM 360 analysis tool. So this is another very blatant example of how bias is there in the AI in the AI systems. Uh, so now with that, so these are some examples. So let's talk about some of the definitions. So what does fairness mean? So now fairness is a pretty generic concept. It is not restricted to an AI system. Any decision-making system will need to be evaluated for fairness when it makes a decision. It doesn't need to be AI. It could be a rule-based system, or any the human mind. When we make decision, we do have evaluation for fairness. So first definition, and the thing about fairness is there are multiple definitions of fairness based on context. There's not a single definition. Like this is not like your precision or recall. You'll say this is the precision and that's it. You cannot dispute that definition. But fairness has multiple definitions and they depend on the context. And many times what happens is one definition of fairness conflicts with another. So that is why you need to consider a data scientist need to consider the right definitions of fairness based on the problem that they're handling. So one definition, traditional definition of fairness was around fairness through unawareness. This is what was very prominent. So basically, you don't look at the sensitive or protected attributes. So in the legal terms, there are certain attributes like gender and race, which are termed as protected attributes. You don't want those to feature in your decision making. And though the fairness to unawareness says, I'm not going to look at protected attributes and that's it, my model will be fair. Now, that doesn't work because we saw in the Apple Card example, even if we ignore those protected attributes, the other attributes are correlated to those. For example, if you collect data on of male versus female, you may find that certain things like in case of employment, the employment hours, employment number of years of employment may be different for males and females, and you could quickly establish a correlation and say which of this candidate is a male or a female based on the pattern of years of experience, based on maternity leaves and different aspects. So there is a lot of correlation in the data. So even if you ignore your uh, protected attributes, the model may still, the data may still have the bias, and the model may become unfair. A popular legal definition of fairness is around demographic parity. So this just says that likelihood of positive outcome should be the same, whether a person is a protected group or no. So this is something that a lot of legal definitions are around it. There's a famous legal rule called 80-20 rule, which says that yeah, whenever you make a whenever you make a decision process, if the decisions are you compare the favorable decisions for one for privileged group versus the other unprivileged group, and if they are the ratio is more than uh, sorry, ratio is less than 80%, if the privileged group is 80% more than 80% privileged gets a privileged treatment. In that case, there is no demographic parity, and this is another metric we'll see in one of our examples. Other metric is counterfactual fairness, which talks about if that particular protected attribute was changed. So instead of male, you were putting female, would you get the same decision? So it tries to look at that aspect. And then two more, I guess, more technical definitions: equal opportunity and equalized odds. This look at the true positive rate and the false positive rate. So the idea here is it not only looks at your uh, decision-making system, but it also looks at your classifier. So if you're building a classifier which rates something as positive or negative, it looks at the true positive rate and the false positive rate, and it is more relevant when you're building a classifier. And this is a nice survey paper on Archive, which kind of I think is by IBM, which compares these different metrics. So it's definitely a nice read. Uh, and when we look at this fairness matrices, typically when we look at a machine learning model performance, we just look at precision and recall. And this is the Wikipedia slide definition of when you look at true positives, false negative, true negatives, and you calculate precision and recall. So precision recall would be something that how you would judge your classifier. But then what fairness asks you to do is look at your privileged and non-privileged groups. Now, privileged and non-privileged could be based on any of these protected attributes. So it could be race, it could be gender. So in gender, privilege typically would be male, and unprivileged would be a female. But it could be, depending on the situation, it could be reverse. So in some cases, it could be a female getting the privileged group. And you would want to look at precision recall for the groups to see if there is a different treatment between the two groups. So the legal definition that talks about disparate impact, disparate treatment, this kind of talks about that, where you look at the different groups, male and female, and for each of these groups you look at. So in this example, if you see, the precision recall is much lower for the male group, while it is higher for the female group. You can clearly see there is a disparate impact that happens between the male and female. So this is something that we as data scientists have to move away from the fairness through awareness concept and get into understanding which are the protected groups based on the context of your problem, and trying to show these metrics for the protected groups, and making sure that there is no disparate impact. Now, to show this as an example, this is an Excel sheet that I had prepared. This is available here at, I've written a blog on this. So on our blog, this Excel sheet is available. All this does is takes two groups, males and females, and it just lets you fill in these predicted versus actual values. So you can choose some, just as, and there is no problem for this. Is just a generic overview of how the fairness metrics are calculated by hand, because a lot of times we rely on these libraries like this IBM AI Fairness 360, Google What If tool. They quickly tell you the disparate impact ratio, equalized odds, and all these things. But these are not rocket science metrics. They're very easy to calculate them. So I just wanted to show how easy it is to calculate these by hand. So if you just know the predicted predicted rates and the actual rates. So here is one means it's a true and zero means a false. So you look at the predicted and actual, it will calculate the true positives, true negatives, false positive. It will calculate your confusion metrics for you. I mean, this is a pretty handy way to calculate the confusion metrics on Excel itself. And then it will calculate the precision recall using the formula shown on the previous slide, the true positive rate, false positive rate. And then more importantly, it will calculate these specific fairness metrics. So it will calculate the disparate impact ratio, statistical parity difference, equal opportunity difference, and equalized odd difference. So though these terms sound very fancy, but they are very straightforward. All they do is compare either your true positive rate, false positive rate, or your selection rate. So that's also the first two metrics, disparate impact and statistical parity. They just look at your selection rate. That is between whatever is selected, how is the unprivileged group doing versus the privileged group doing. The other two metrics look at true positive and false positive rate. How is the selection? How is the privileged group doing? Unprivileged group doing? So I won't go through it in this session because I want to spend time on the AI Fairness 360 library, because that's something that will let you do debiasing also. So it's pretty handy. But you can have a look at the Excel sheet and just see how these metrics are calculated. So this is something pretty handy. There's a blog also describing these metrics, kind of what I covered in this slide. So you can go through this offline. So rest of I'll spend 10 minutes just showing you this demo, and then I'll take a break of 5 minutes, and then we'll come back to responsible AI and some of the work that we are looking at specifically on how to manage this. So let me spend some time on this. Are you seeing my browser window just to check?
Yeah. Yes.
Okay. Cool. Thanks. So this AI Fairness 360, this is a nice tool by IBM Research, and what it is it gives you this library, so you can look at Python library, and like I said, it will give you a quick way to calculate fairness metrics. But also more than that, it will also, if you have a biased data set, so when you take a data set, you know that this data set is biased after calculating this metrics. What it will do is it will actually help you do debiasing. So by adding some noise to the data, you can actually remove the bias. And this tool will have some handy way to actually do it. And then there are different ways to do it. You can add different types of noise where you're adding noise, focusing on the bias so that you can reduce the bias and then calculate the metrics to see how the bias has been reduced. So when you're building a machine learning model, you want a relevant data set, but you want a data set which is less biased. So you want to apply some of these tools to actually reduce the bias in the data set. But what I really like is the demo that they have, which is something you can just try it out. In fact, right now you can open this up and try it out on your own. There's no login, nothing needed. So what this does is it lets you select one of three data sets. The library would let you experiment on your own data set. I mean, that's you have to do coding. But in this case, it quickly lets you look at three data sets. And we'll choose this data set, the Compass data set, which ProPublica used for recidivism, where the protected attributes were sex and race. They don't actually show the data set. So let me quickly jump to a screen where I have opened this data set. So this is the actual data set. If you look at my Excel, so what they do is they have this person ID, assessment ID, the names of the convicts, uh, the gender, the race, date of birth, and bunch of things. And then there is a decile score. Decile score is which will tell you it's a score between 1 to 10, and 10 is high and 1 is low. So 1 means there is a low risk, and 10 means there's a high risk. So it's a straightforward CSV. This actually is from their website only, and you can go to you can just click on this data set, and this is a nice GitHub link where this data set that I've shown that is available. So if you want to run this analysis on your own without going through the tool like R or Python code, and this will be a nice mini project. You can take this CSV file, and they have actually given you a nice notebook here. I believe this has a lot of R code, so you can convert this into Python. But this will actually do the same analysis, go through your CSV, and it will do a check on bias, etc. So you can have a look at this. It's a very nice notebook. But I will show in this case. In this case, I'll just show this being done in a tool. So I'll select this data set and hit next. So now what it is doing is behind the hood, it is actually running a calculation from that CSV data set and trying to calculate bias for you. So it is finding you this five matrices. The first is statistical parity difference. So you can just click on statistical parity difference. This will tell you exactly what. This is the same thing I have used in my Excel sheet. It's the same formula where it is basically calculation computed as the difference between the ratio of favorable outcomes received by the unprivileged group to the privileged group. So it is basically your selection rate. So when you divide your data set into two, unprivileged and privileged, how is the selection rate differ between them? The ideal value is 0. That there should be no difference. But minus zero point 0.1 to zero point 0.1 is the range. Beyond that, there will be bias. So I mean, this is like a best practice that IBM has provided to you. So if you look at the analysis that was done here between for the protected attribute gender or sex, you see that the value is minus 0.36. So this is definitely a bias value. So that's why it's showing bias in red. It is quantifying the bias for you. It is telling you this minus 0.36 is the statistical parity difference. So it is telling you how much bias this data set has. The same thing goes with equal opportunity and or let me go to average odds first. Average odd is again looking at the selectivity, disparate impact. Disparate impact is again looking at the same favorable versus unfavorable selection rate, but it is looking at a as a ratio. So, and this ratio value is between zero point 0.8 to 1.25 would be considered not biased. But then when the value is like a very low, like 0.59, it will be something. It will be considered biased. Same thing, equal opportunity, equal odds. You can look at the definitions here. So equal opportunity will be the difference between true positive rates between unprivileged and privileged groups. So the true positive rate is calculated, and between unprivileged privileged, what is the difference? And again here, minus zero point 0.1 to zero point 0.1 is the range, and you see that there's definitely a bias because the value is minus zero point 0.3. And then average odds difference. Here you are looking at true positive as well as false positive rate. So false positive rate and true positive, it is looking like a weighted average between the two, and based on that, it is calculating your uh, uh, average odds difference. And Thiel's index looks at the entropy. I mean, I've not covered it, but you can read on it. There's a paper on it that describes the calculation, but it looks at the generalized entropy and shows based on the entropy difference between privileged and unprivileged how the bias is incorporated. And then again, you'll see for a different attribute race, you'll see there is still a bias here, and there's a bias for disparate impact. So race and gender both have bias. So when you hit next, now what the library does allows you to do is allows you to fix bias. So you have this data set now. This is the real world data set. You cannot you don't want to discard it. I mean, it is actually has a very good domain knowledge, but you want to add some noise to the data set so that you get rid of the bias. So there are three ways to do that. You could either look at the data itself and apply the debiasing at the data. You could look at the classifier, the machine learning model you're building, and apply the debiasing. Or you could look at the predictions by the model, and when you have the predictions, you can reduce the bias there. So these are the three approaches, and each approach has its pros and cons. You can learn about which approach, and also it depends on how much control you have the data set. If you cannot change the data set at all, it's a hard restriction. Then you would want to look at the classifier or the prediction. Uh, so one approach is reweighing. Reweighing basically just assigns a different weightage to these different groups, or you could do some pre-processing, some feature engineering to change to debias the data. There's adversarial debiasing, which actually builds an alternate model, and it tries to look at how easy it is to predict the sensitive feature uh, from the prediction. So from based on the prediction, can you say that this prediction was done for a one of the protected attributes? So you look at the adversarial debiasing, and then the final thing is reject option-based classifier, which is more of a which looks at the prediction. So the idea here is it actually changes the prediction. It doesn't touch your data set, doesn't touch your machine learning model, but based on it just changes your prediction. It's some predictions which tend to be on a border, which are because of bias, they are actually flagged as negative. It will turn them into positive or positive to negative. So these are the three approaches. And what you can do in this tool is you can just click on one of them, and what it will show you is uh, it will apply this technique, and it will say based on the older data set how the bias changed. So earlier we saw that the statistical parity difference was minus 0.36. Now it became 0.03. So it definitely reduced the bias in this. So it added some noise to it, but it reduced the bias. Same thing here. It increased the disparate treatment from 0.59 to point. It made it to 0.95. So now it has made it more fair. So this is a technique by which you can apply debiasing and reduce the bias. The idea is to balance between your performance and debiasing. You want to retain as much as the original data set, but apply enough noise to get rid of bias. And that is what this library tends to helps you do. So you can actually download a nice notebook from that and try this on a real world data set. So you can download this data set, uh, Compass data set, look at the bias calculations and apply your reweighing of this technique, adversarial debiasing, and actually reduce the bias and see the effect of the reduced bias. So that was the IBM tool. Feel free to try it on some of the other things, and I definitely highly encourage you to have a look at this Python API. Or if you are more familiar with R, you can try it out in R. It's definitely something very interesting, and you can try out different data sets. Like you can look at either one of these, the Compass data set, which is a very famous example, or the German credit scoring data set, or an adult consensus income data set. And each of them have certain protected attributes and certain decision points. We can look at this analysis and try out a notebook and see how well this uh, how the bias exists and how you can fix the bias.